Nikita Sapozhnikov.
I'm David Guzman, many of you know.
Yes.
We're going to talk today about rapid microservice development with Microserver, but first of all, we want to mention what a microservice is a little bit because it seems to be a confusing term. Like many people, when you look on the internet, many people give different definitions of what it is. We looked at a definition provided by Marvin Fowler, and he says it's more of an architectural style in which you can see an application as a set of smaller components that communicate with each other using lightweight mechanisms like HTTP REST calls or lightweight communication protocols. So the way we've been seeing applications before were based on big common libraries where we built our applications on top, and we instead microservices approach this problem by breaking that down into different smaller services using several criteria, such as the easiness of deployment or business functionality. For example, we have Lana API, and instead of adding onto Lana API project, we create microservices that talk to Lana API to provide with price volume curves or to provide with other sorts of forecasting services. In the back end as well, instead of adding to our legacy Lana common library, if we want to communicate with S3 or with or use database pool like HighCarryCP or DBCP, instead we're adding plugins to, in this case, the microserver library, and we're using them in any of our projects that we create. So other criteria we can use is technology deployment, so we can have a microservice in another technology, not necessarily Java, but that's lightweight and that can talk to our Java services as well. So microservices solve the problem of like repeating ourselves by maybe copying code or depending on common libraries and splitting that up into plugins that cross with services on top of them. And this is what John created a few months ago. Microserver is, in this case, we only have 9 plugins, but there are now more than 30 of them, where every single functionality backend, frontend, we push that out into a plugin, and whenever we need to build an application, we just take from these plugins and build it up. It's based on Spring, and currently it also supports Spring Boot. So it was launched at the time Spring Boot didn't exist, so that's where John saw the need to create this. For me, it was a good way to transitioning from QA into development because I didn't know the code base. Sometimes I know in your projects that you may have like big chunks of common libraries that you wouldn't understand how the different components interact with each other. In my case, it's very easy to maybe create a plugin or to build an application just by putting the pieces that I needed to deploying that in production. That's what we want to show you today.
Is a plugin when we talk with reference to Spring?
Yeah, we're gonna, so in this talk, first we're gonna describe, as I'm doing it right now, what a microservice is. Then Nikita is gonna show you how microserver gets built up. And I'm gonna show you how to create a plugin. We're gonna do a micro Slack plugin. And with your phones or your laptops, we're gonna do a small demo about it. Okay?
As David already mentioned, Microserver is somehow similar to Spring Boot, but if it would be just a clone of Spring Boot, would be not very useful. So there is some differences which are advantage of Microserver. One of them is different mechanism of loading plugins. Spring Boot just scan all packages, so the more packages you have, the longer your application starts. Microserver use service loader mechanism. How it works? At first we declare interface, it's called plugin. When we provide multiple implementations for that plugin, each implementation provides list of beans that should be initialized by Spring. So if you split your application into plugins with just beans you require, it will start faster than similar Spring Boot application, which will scan for all packages. Important thing about service loader is not just implementing plugin and declaring plugin interface and implementing it. You also need to create service loader file. It's located in each jar file by this path, and content is a list of initialized of plugins you want to initialize for that jar file. So you potentially can have multiple plugins in same jar file. As you can see, service loader just read those files and initialize those bins, so it's pretty simple mechanism. It's implemented since Java 6. We wanted to show you simplest possible microserver. It's like 33 lines at all. We'll see all the code for it. As Lana team usually use Gradle as build system, Microserver is not limited to using just Gradle. It can work with Ant, I think Clay again, Maven, whatever. Important things on this slide. Since we deploy our applications as jar files and single jar files, we need to merge all dependencies into single file. That's why we use shadow jar plugin. And we declare dependencies we need as microserver with Grizzly. We also need to merge service files. Remember on the previous slide I showed you a file containing list of implementations. If you use different plugins, default behavior, it's all plugins will override this service file, and you will not have all plugins you want to initialize. To avoid it, you need to implement that behavior. It's provided by most of the build system. I'm sure that it's present in Ant and Maven, and as you can see, it's provided in Gradle. Other than that, it's greatest basic build script for Gradle. Here's entry point for microserver. Non-standard things here is microserver annotation. It's allow you to configure microserver with some properties. For example, you still may want to scan some packages in Spring. You may want to have some additional property files or something like that. Basically, it's replacement of Spring configuration. Another thing is microserver app. Microserver app is basically main entity holding all microserver stuff. Potentially, as David will show later, you can launch microserver app in Spring test, in unit test, and then kill it after test will pass. So you can test your microserver like it working on real machine. The first here is just context name. It also will be part of URL. And here the service, as you can see, it's really basic. We just declare status path, and on any GET request returning OK. Standard things here, quite standard, are GET and path annotations. They are from JavaX REST. And non-standard thing is REST annotation. REST annotation is replacement for jersey configuration. It's mean that this class should be exposed through HTTP. It simplifies configuration, so you can declare multiple annotations. When you're debugging something, you can just command REST annotation, so you need to change less code when you will do it with some configuration. For this slide, I just wanted to show the last step of writing code, just building it. As you can see, it's not take much time. We need to mention that we didn't download the partitions in 3 seconds, all dependencies in 3 seconds, so we downloaded earlier, so they cached. It may take longer depending on your network connection. Microserver has 30 plugins, but unfortunately sometimes you may want to add something, or you may want to write new application from scratch using only plugins, so to make it run faster. So David will tell you how to implement Slack plugin.
So in this case, to create a plugin, we're gonna start with a build a grader file. Where we're gonna need, and for the core of the plugin is just microservices with Jersey, because we're gonna provide a REST endpoint that will ping. As well, for testing, we're gonna use rest assured. So that's very straightforward. So Slack plugin class is going to contain whatever we want to expose. Let's say out of a set of 10 different classes, we want to expose 2. In this case, we want to expose the configuration class where we're going to hold our webhook for a Slack channel, and Slack REST where we're going to hold our endpoint. This is the Slack configuration. It only has one attribute that we call webhook URI. That's where we're going to configure later on. It's important to say that we use logbook as well, and that's why you see the getter annotation on top. That would be the only non-standard thing you can see in the code. And this is the Slack REST. So we'll provide with one endpoint message. Whenever to make it simple, we made it a get request. So whenever we try to get /lag/message and we provide a text, a parameter, that parameter is going to get posted onto Slack. To make it production ready or to release it with Microserver, it should be a post request instead. This will also contain the configuration provided by the Slack configuration class. Now, this is the class that will send a message to Slack. We just use a standard, you can use a standard library. We're not going to focus on that, a standard library to do a HTTP call onto the webhook. So how does this plugin work with the less than 30 line microservice Nikita showed you before? In this case, the build.gradle gets a little bit complicated, but I want you to concentrate on the highlighted line, which is we only added microgrizzly with Jersey for the endpoint, and we added this newly created microslack. In my case, because it's not released in production, I created my own jar, and it's on my local machine, and that's why you can see on top flat there as a repository. And also, for this demo, we deployed into Heroku, so you can see other tasks called at the end of the file, task stage, and you can see archive space name, but you shouldn't pay attention to that because you all have your own pipelines and your own ways of delivering microservices into AWS or into physicals. The point here is with one line, we can, on the build.gradle file, we can add a plugin to our service. So, because I come from a QA background, I want to show you the test first. So, in this test, we create a dummy service, and on the before part and on the test, we're using JUnit, of course. And as you can see on top of the test, we add the microserver annotation to tell the test that we want to use Slack configuration and Slack REST classes, and then we inject those variables there. And on our test, we're just going to ping that test using rest assured in order to get an OK status, so a 200 status code. And what you see is just after adding one line on the build.gradle, you add another endpoint, in this case ///message in the application at the bottom. So microservices are, with Microserver, are an easy and reliable option to develop a new service. It's not only throwaway code, it's code that can be developed further into production code, so it's not just for prototyping, it's reusable. It's go-to for refactoring if you're moving away from your common libraries. I'm sure many projects there are common libraries that you don't want to maintain. It also encapsulates functionality. So whenever you think of some shared functionality by your different components, like, I don't know, talk to clusters, how to Aerospike, I don't know, whatever, metrics, then you can think of a plugin, and it would be great if you can add it to this repo. And it ensures maintaining consistency, so we won't repeat ourselves in the code. Now, for the demo today, we prepared a channel. If you can join it on your phones or on your laptops, it's called TechTalk-Micro. We're going to show you that on the screen as well. And to ping this channel, well, I use Heroku, so that's the That's the URL. If you can type it on your phone, or when you join the channel, it's pinned on the channel. So the URL is pinned there, so you can just test it by tapping on the pinned message. So we're gonna see a lot of your text there. So we can see who's joined. Of course, this is a very simple demo, so it's like prone for trolling because it doesn't say who sent the message. Like it doesn't get any cookies or anything from the sender. So basically, you can post whatever you want. For now, people won't know who posted what. So, but the point is, with less than what Nikita showed you, less than 30 lines of code, and I just showed you a service with one extra line. You added a plugin that talks to Slack.
There is a second important thing in that plugin. If you add it to your application and there will be unhandled exception, this exception will be sent to Slack channel too.
Yeah, of course, like this is not production code, so you need to add a few validations and filters there. So let me just write that myself. Yeah, there you go. So we can just keep playing with it. So Microserver has more than 30 plugins already. We can talk to S3, we can use DBCP or HikerACP for our databases. We can use Jersey, Grizzly to spin services based on those technologies. Guava, there's MicroReactive as well that integrates with another Cyclops React, another library. And then you're welcome to add anything you want that we for sure would make use of that as well.
There's a Datadog plugin that seems to be
There's a
really ready to
Datadog.
go as well.
Yeah, the idea in my case, the idea is to make the Slack plugin ready for to release with Microserver, like some proper validations and stuff. No more trolling. And yeah. So thanks. And any questions? No.
Left guns on the floor.
What is what are people's experience of managing a project or a deployed system as a set of microservices? How easy is it to maintain the system? Debugging if something's going wrong, how easy is it to find that type of thing, operational issues?
Most issues we met, I think, mostly related to service detection. Like sometimes we deploy service and it points to wrong microservice because someone forgot to upgrade properties. Usually, all those debugging relates to checking logs, seeing some connection exception, something like that, and then just checking. Do we have proper properties? It can be avoided with planning how we do those integrations. For example, we can log address we are trying to connect to in log it, like not always, but something like probabilistic logging. Log it once in 10 times, something like that.
Mm. And so let's say you've got a service at the top level, and that service is implemented. It's maybe 10 or 12 microservices underneath. and so you send in your request at the top level, and something has gone wrong with one of the microservers. How easy is it to track down the thing that's gone wrong in this type of architecture?
In this type of architecture, I think it's important to have some identifier for request. So when you are doing it, so you, for example, entry point like LAN API in our case, can generate random identifier like GUID, and then every time you see any log message, you just put that GUID. It's simplest way I can imagine for debugging anything related to that. It's one approach. Second approach we had, when you have limited amount of services, we did it for AOP and working with LAN API. We just return exception from other service. But if you have, I don't know, like 10 services, so that long stack trace is not a good thing to deal with. Potentially, I'm still thinking that using identifier, especially if we have Kibana or something like that, should be a good way, enough way.
You just have all your application logging to Datadog, for example, and then you search by request ID or something like that, then you see which service has logs information related to that. Maybe the easiest way to track it.
There's tools like Zipkin, I think, can probably help with that a lot as well, though we don't use that. But I know that some of the other teams here have experimented with it.
Yeah, it's just, the benefits of breaking out the system are fine in terms of you can work on each of those components independently. But then you still need to be able to manage, for the whole system to work, all of those dependencies need to work. And then you have to figure out how do I track down all those.
Yeah. Like, you solve one problem and another one opens up.
Yeah.
You get faster development and independent deployability, but then you've got a more complex system to manage. Yeah.
Do you have any microservices in systems based on microservices in production?
We have Lana. It consists from like 20, I think, microservices, 25.
Probably 20, somewhere between 25 and 30 distinct services with 75, 80 distinct instances in production.
So it's 3 different setups globally, is it? How do you?
Well, so like we've say 25 distinct types of services,
Right.
but that winds up as being, let's say, 80 actual services deployed because of multiple versions of.
Okay.
Multiple instances of the same.
Yeah, exactly.
So when you deploy, do you decide beforehand what combination of microservices goes on each server? Or, so when you deploy a new server, is it a certain amount of X, a certain amount of Y, and a certain amount of Z? Or do you just...
So in physical hosts, that's exactly what we do. We pre-plan it. On AWS, we don't really have that freedom because we're using ECS. But the clusters are kind of sized appropriately for the services that will go in them, but they could be randomly distributed across any given host.
So if you needed more X, you'd spin up more X instances that had a certain number of X.
Yeah, so we've been separating the clusters in AWS by type of service. When we have like big services like with 120 gig machines, something like that, and then we're just testing upscaling and downscaling. It's not ready yet for production. But if need be, like this architecture provides a way to spin new instances of the same service, and then they would register themselves with some sort of centralized discovery service or registry service who knows where they are and is able to talk back to them as well. So that's one of the plugins actually.
One of the more controversial features of Microserver, especially like for people externally, is the fact that you can bundle up within a single JVM or single process a lot of microservices, which simplifies the deployment.
Yes.
But obviously you don't get your independent deployability
you don't get full, flexibility.
Right, but you do get faster development
maybe
time.
very efficient communications.
Yes, you do. Yeah, much more efficient communications, easier to manage a single deployment, but it's not a pure microservice in that regard.
You don't have to be pure to be good.
Yeah.
The other in an AWS context, and this is something that we're becoming much more aware of now that we have more stuff in AWS, is that data transfer costs can become significant in AWS. And again, depending on your deployment strategy here, you could be, have a very flexible system, but find yourself paying, much higher than expected data transfer costs because you're moving requests from one availability zone to another, which
Right.
would a normal deployment scenario. But now, because you're sending a lot of requests, a lot of small messages, your data transfer costs are ramping up in AWS, and you never would have expected that.
Yeah, no, exactly. I don't think you'd want to be distributing your microservices across availability
Yeah.
zones, at least having frequent conversations between them across
Well,
availability
You
zones.
clearly need to, at some level, to get availability.
Yeah,
But you don't want your conversations continually going
Right.
across availability zones.
yeah. Like it should be coarse-grained rather than fine-grained conversations across availability zones. or something.
Well, again, the idea of having a server where you have some X and some Y and some Z on the same server, that avoids that problem.
Right.
But where you have three clusters, one of X, one of Y, and one of Z, and each of those clusters is split across two availability zones, now you've got
Yeah, yeah,
a data transfer problem.
exactly.
Do you find you have much chatter between plugins, and how do you manage that? Are they all HTTP connections, or what are you doing sort of for inter-service communication, or is there any need for inter-service communication?
We have microclient library as implementation of REST, but usually we're just Jersey on the server side and REST microclient on the client side. So I think we can maintain our own connection pools. So we don't.
So
So
you tend to use REST and you
Well,
talk between services. But I don't know how much it happens. Or
Yeah,
how much happens.
it depends. I mean, like Microserver provides a REST API, but not all the services communicate with REST. For example, one of the services that Nikita wrote that's effectively communicating with one of your services is using Thrift, and then there's other different communication protocols used internally. But I guess as well for our project, it's not. Our requests are typically reasonably long running. I mean, talking long in milliseconds terms, and they're computationally intensive. So you don't get like billions of queries, but you do get like a large number of longish and computationally intensive queries. So and those are normally handled by HTTP requests, but the overhead of that in our case is, as a portion of the work we're doing, is quite small. But like, for example, that place where we're communicating with you guys via Thrift, that is like, a large amount of communications are coming out really, really, really quickly.
Yeah, we're considering ourselves HTTP really isn't a good protocol for that. There's too much chatter on it.
Yeah. Thank you. Thanks, guys.
Thanks.
Thanks a lot, guys.